Alrighty, folks, so now we're going to look at the next topic in statistics, which is going to be frequency tables and histograms. Now, these things are really reminiscent of the bar graphs that you drew in junior high, but the rules are just a little bit stouter around histograms. So we're first going to look at how do we create frequency tables, and then how do we use frequency tables to get histograms, and something called a frequency polygon that goes along with that. And we're going to talk about interpreting and understanding data distributions just a little bit to get an idea of how a histogram is so useful for us. And that relates to what we did last time with dispersion. Okay, so frequency tables. First of all, what we have here is an example similar to what we talked about in a previous session, just some student test scores. So we got a class of 20 students, and these are all the grades that they got on a particular test. So what we do before we create a histogram is we organize the data into the bins. Okay, so we take each data value up here and we fit it into one of the bins. Is it a mark between 50 and 60, 60 and 70, 70 and 80, 80 and 90, etc. So let's go through them all. Won't take very long. So 75 is definitely a mark in the 70s, so we'll put a mark there for that tally. And we got 63 goes in the 60s, 52 goes in the 50s. All right. We got one for the 80s and one for the 90s, one for the 80s, one for the 90s, one for the 50s, one for the 70s. Okay, it's a bit arduous task. Computers do this really well for us. Another for the 80s and another for the 90s. Okay, and now we got an interesting one because when we get a mark of 90, where do we put that? Does that go with 80 to 90 or 90 to 100? Well, by convention, we put it in the interval that starts with the 90. So we're going to put it down here with this one. Okay, and some textbooks will actually do that differently, but that's the way yours does it, and that's the way we're going to do it in this course. So we get a 78 and a 62, so one in the 70s and one in the 60s. And let's see, 60s and 2 for the 70s, so 1 60s and 2 for the 70s. Tally means the line there. And 2 for the 80s, 1 for the 50s, so 2 for the 80s, 1 for the 50s. And 160 and 180 there. So we got one in the 60s and one in the 80s. So we got tallies of 3, 4, 5, 5, and 3. So that's what we call a frequency table. We organize the data into neat and tidy little what we call bins or categories, and then we just count how many of the data values fit into each category. Then what we do is we use that frequency table. So you can see I've copied the same frequency table right here. I just left the tallies out. We use that to create what looks a lot like a bar graph that you did in junior high, only now we call it a histogram. So for the 50 to 60 interval, I've only got 3. So you see what I have over here on this vertical axis is the frequencies, okay, and I have to go up as far as the highest one there, which is 5. And on the horizontal axis, I have test scores organized into the bins that we talked about, okay? And there's no spaces between the bars on a histogram. They have to line up one after the other unless there's a bin that has nothing in it. So the first one, for the 50s to 60s, we've got to go up as high as 3. So we've got to draw out what we call a rectangle here. Now, I'm doing this freehand, so forgive my lack of artistic impression. So we've got to draw a rectangle for 50 to 60 that has 3 in it. And then for the 60s to 70s, so the 60s interval, we've got to go up as high as the 4. So it's going to look more or less like this. That's the world's ugliest rectangle. And then for 70 to 80, we've got to go to 5. And I think the next interval after that also goes to 5. So we'll make 2 rectangles here that are going to be about the same height. So there's one for the 70s, and there's one for the 80s. And then the last one for the 90s only goes up as high as 3. And we get that one drawn, and la-da-da, we have our histogram. Some folks tell you you're supposed to shade those in or whatever, but it's not really all that important. So that's what a histogram is. So it sort of gives us an idea of how the data are distributed or spread out. So here are 2 examples. For this first one, it's talking about the girth of rainbow trout, of all things. So if we take a look at the data here for this particular histogram, what we can see is that we would guess the mean value, or an average one, would be somewhere around here in the middle, somewhere around 4.3. And we can see that the spread of this data, you could measure the range, and if you knew what all the data values, you could calculate the standard deviation. And well, if we want to get sort of an idea of the shape of the data distribution, okay? So what we do to get an idea of the shape is we just sort of put a dot at the midpoint of all of these, like so. And when we put all those dots in there, we're going to play one of our favorite games from childhood, which is called Connect the Dots. And when we connect all those dots, usually we just use straight lines to connect them, we get kind of a shape. And that shape that we get will have sort of these jagged corners and stuff on it. And it looks like one of the shapes you drew when you were a kid too, or in math class when you were in elementary school. And we call that funny shape a frequency polygon. So you probably have heard of it as a line graph, but the correct name for it is a frequency polygon. So that's a frequency polygon. And if you had a histogram with a whole lot of different bins, and we had all kinds of bars, then the more bars we had, the smoother that sort of shape would become and the less jagged it would become. Okay, so let's draw a frequency polygon for this one. It's going to be a little more jagged because we don't have as many bins or categories on this particular histogram down here. But if I draw this one, I get a shape that kind of looks like this, and it's dancing around all over the place. I'm supposed to be hitting those numbers right on. You can tell I'm not a great artist, as I've said before. Okay, so if I had to compare these two, I'd say this one had a mean right about here, and I would say this one had a greater degree of dispersion. The second one is more dispersed, so because it seems to be a little more spread out compared to its mean, relatively anyway. But we've got frequency polygons and we've got histograms, okay? So we start by creating a frequency table. We do that by choosing bins and organizing the data, not the date, into tables, or sorry, into particular categories. Then that creates a frequency table. We can use that to create a histogram by sketching the appropriate bins, kind of like a bar graph. And a histogram allows us to visualize the data distribution. We can estimate the mean and get an idea of the dispersion from the histogram. And it also allows us to draw a frequency polygon. Thank you. Hope it helps.